Hello everyone. First of all, I want to say best of luck and best wishes for your GATE exam. ओके सो पेपर के अंदर सबसे इम्पोर्टेंट चीज़ क्या है? आपने जितनी भी मेहनत करी है पिछले पूरे एक साल के अंदर, जितना भी एफर्ट दिया है 7 मंथ्स 8 मंथ 9 मंथ 10 मंथ्स, वो पूरा का पूरा उसका रिजल्ट जो है वो आपको एक 3 घंटे के पेपर के अंदर आपका निकलेगा। तो इसीलिए इन माय व्यू आखिरी में बिल्कुल भी घबराने की ज़रूरत नहीं है। लास्ट टाइम के अंदर हमेशा ऐसा लगता है हमें लास्ट वीक के अंदर कि हम बहुत सारी चीज़ें भूल रहे हैं, पर ऐसा नहीं है। जैसे ही आप चीज़ें पेपर के अंदर जाएंगे और अगर आपने प्रॉपरली रिवीजन कर रखा है चीज़ों का, तो डेफिनेटली यू आर एबल टू रिकॉल ईच एंड एवरीथिंग। बहुत ज़्यादा जल्दबाजी में पेपर में गलती मत करिएगा। बहुत आसान क्वेश्चन जब आएँ तो उसके अंदर मिस्टेक्स होने के चांसेस बहुत ज़्यादा होते हैं। तो उस केस के अंदर जल्दबाजी में नेगेटिव मार्किंग के ऊपर भी ध्यान रखना है। ऐसा ना हो कि कोई क्वेश्चन जो आपको बहुत आसान लगते हों, आपके फेवरेट टॉपिक से आ गए हों, और उस केस में आप जल्दबाजी में क्वेश्चन में मिस्टेक कर दें। ओके, तो इसी वजह से एक क्वेश्चन को करने का ऑलमोस्ट 2 to 3 मिनट्स 4 मिनट्स आपको पेपर में मिलता है। तो किसी को भी क्वेश्चन को सेकंड्स में करने की कोशिश मत करिएगा। एंड फोकस ऑन द एक्यूरेसी। द मोस्ट इंपॉर्टेंट पॉइंट इज एक्यूरेसी, क्योंकि अगर आपने 6 से 7 महीने प्रैक्टिस करी है और अच्छे से तैयारी करी है तो स्पीड आपकी अच्छी हो चुकी होगी, बट पूरा का पूरा मैटर करेगा सिलेक्शन के अंदर, टॉप रैंक के अंदर, सिर्फ और सिर्फ कि कौन अपना चीज़ों के ऊपर, अपने इमोशंस के ऊपर कंट्रोल कर पाता है और आराम से पेपर को एनालाइज करके क्वेश्चंस को कर पाता है। ओके, तो लेट्स स्टार्ट विद आरएसी। हम कुछ क्वेश्चंस प्रैक्टिस करेंगे। डेफिनेटली आपने बहुत सारे क्वेश्चंस पहले ही प्रैक्टिस कर रखे हैं। गेट के क्वेश्चंस हैं, ईएस के क्वेश्चंस हैं, वर्कबुक हैं क्लासेस के अंदर बहुत सारे क्वेश्चंस आपके साथ हुए हैं। तो जस्ट ये आपके लिए एक प्रैक्टिस के लिए है। तो साथ में हम क्वेश्चंस के साथ में हम रिविज़न भी कर पाएंगे। ओके, सो थोड़ा सा अगर हल्का सा भी कहीं डाउट होगा तो यू आर एबल टू अंडरस्टैंड दैट पोर्शन ऑल्सो। तो दिस इज योर फर्स्ट एंड वेरी 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 बेसिक क्वेश्चन। ओके, बट हमने देखा है कि लास्ट 20 ईयर्स के जब आप पेपर देखेंगे तो कि कई बार गेट के अंदर, इंजीनियरिंग सर्विसेज में, स्टेट पब्लिक सेक्टर्स में, सारे टाइप के एग्जाम्स के अंदर आता है। ओके, सो व्हाट इज द फर्स्ट क्वेश्चन? द फर्स्ट क्वेश्चन इज द कार्नोट रेफ्रिजरेशन रिक्वायर्स 1.51 किलोवाट पर टन ऑफ रेफ्रिजरेशन। किलोवाट पर टन ऑफ रेफ्रिजरेशन, तो इसके अंदर एक सबसे इंपॉर्टेंट चीज है पर टन ऑफ रेफ्रिजरेशन। सो क्वेश्चन के अंदर ही उन्होंने डाटा दे दिया है रेफ्रिजरेशन कैपेसिटी का। ओके, रेफ्रिजरेशन कैपेसिटी का, तो ये डाटा आपको ध्यान से पढ़ना है। टू मेंटेन आर रेफ्रिजरेशन एट अ लोअर टेम्परेचर ऑफ -30 डिग्री सेल्सियस एंड द हायर टेम्परेचर ऑफ द साइकिल इज, and you have to find out in degree Celsius. Okay, you have to find out in degree Celsius. So कार्नोट रेफ्रिजरेशन साइकिल, तो जो सीओपी होता है ऑफ द रिवर्स्ड कार्नोट साइकिल, ओके, सीओपी जो होता है ऑफ द रिवर्स कार्नोट साइकिल, दैट इज इक्वल टू टी लोअर अपॉन टी हायर माइनस टी लोअर। तो रिवर्स कार्नोट सीओपी इज अ फंक्शन ऑफ टेम्परेचर लिमिट्स ओनली, इट इज इंडिपेंडेंट ऑफ द वर्किंग फ्लूइड। मैं बहुत सारी चीजें आपको इनडायरेक्टली वो भी डिस्कस करूंगा जो पेपर के अंदर आई हुई हैं, तो आप ऐसा मत समझिएगा कि दिस इज द ओनली क्वेश्चन विच वी आर डिस्कसिंग। ओके, सो इनडायरेक्टली एक तरह से ये थोड़ा सा रिवीजन सेशन भी होगा और साथ में आपके पास क्वेश्चंस की भी प्रैक्टिस होगी। तो रिवर्स कार्नोट सीओपी का फॉर्मूला ये होता है टी लोअर अपॉन टी हायर माइनस टी लोअर, एंड रिवर्स कार्नोट सीओपी इज इंडिपेंडेंट ऑफ द वर्किंग फ्लूइड, एंड इट इज डिपेंडेंट ओनली ऑन टेम्परेचर। ओके, ओनली ऑन टेम्परेचर। बट इस क्वेश्चन में प्रॉब्लम क्या है कि टी लोअर तो आपको दे रखा है बट द टी हायर इज नॉट गिवन। सो टी लोअर, कैपिटल T is the temperature in Kelvin. So 273 minus 30, so it will come out as 243 Kelvin. Okay, now we have to find out T higher, but COP is not given and T higher is also unknown. So COP can be find out by another way. COP basic formula is refrigeration effect upon work input. So the Carnot refrigeration requires 1.1 kilowatt. Okay, it is consuming the power input. So work input is 1.1 kilowatt and 1 TR. Okay, 1 TR, and 1 TR is equivalent to how much? How many kilowatt? 3.5. So 3.5 divided by 1.1. Okay, 1.1. Through this the COP will come out as 3.1818. Okay. So now therefore the COP value is 3.1818 and it is equal to T lower, okay, T lower upon T higher minus T lower, okay, minus T lower. So into 243, Okay, so T higher minus 243 is equivalent to 76.37. ये आप कैलकुलेट करके देख लीजिएगा, मैं आपके सामने कैलकुलेट कर रहा हूँ 243 अपॉन 3.18. ओके, एंड प्लस 243 plus 243, okay, plus 243. So from here you will get T higher as 319.37 Kelvin. Okay, so the most important thing is, मैंने क्या कहा था आपको सबसे पहले स्टार्टिंग में कि प्लीज फोकस ऑन एक्यूरेसी, प्लीज फोकस ऑन एक्यूरेसी. स्पीड आपकी अच्छी हो चुकी होगी ऑलरेडी अगर आपने प्रैक्टिस करी है 6 से 7 महीने. ओके, तो डोंट बी इन हरी इन द एग्जाम. यहाँ पे दे आर प्लेइंग विद यू. ओके, ये डिग्री सेल्सियस में आपसे पूछा है और यहाँ हमने केल्विन में निकाला है, तो -273 आप इसमें करेंगे तो 46.37. ओके, सो द आंसर इज 46.37 डिग्री सेल्सियस, 46.37 डिग्री सेल्सियस. तो दिस इज द आंसर. तो प्लीज टेक केयर ऑफ द यूनिट्स. ओके, द मोस्ट इंपॉर्टेंट पार्ट इन द गेट एग्जाम, अगेन आप इफ यू हैव ऑलरेडी अटेंडेड माई क्लास तो यू ऑलरेडी नो दिस थिंग कि आई हैव रिपीटेड this statement more than 1000 times in the class कि gate means accuracy, gate means unit. Okay, accuracy and units are the most important part. So okay, so please take care कि in your time they can ask in Kelvin, okay, or they can ask in degree Celsius. तो please take care of the units. Okay, तो जल्दबाजी में आते हुए क्वेश्चन को गलत मत करिएगा. Okay, so the answer for this question is 46.37 degree Celsius. Okay, this is your question number 2. Okay, so in this question there are 4 parts. Okay, refrigeration capacity in tons of refrigeration, power input in kilowatt, COP heat rejection across condenser in kilowatt. Okay, so in your gate exam, with respect to your gate exam, okay, they can ask one part in 2 marks. Okay, RC in 2 marks, COP for 2 marks, power input for 2 marks, heat rejection across condenser in 2 marks. Okay, or common data or numerical answer type. Okay, they can mix in this manner. Okay, so I thought कि instead of discussing the single part, get determine RC in ton. Okay, I thought कि with the help of this question we are able to revise the concept of VCRS, vapor compression refrigeration system, and indirectly in a single question we are able to discuss 4 parts almost. Okay, so the following data refers to a single stage vapor compression refrigeration system. The refrigerant used is R134A. Okay, the refrigerant used is R134A. So R134A, it is not important with respect to this question. Okay, not important with respect to this question, but there is one chapter called as refrigerant in which R134A is asked so many number of times. It is called as eco-friendly refrigerant. It is called as eco-friendly refrigerant, and C2H2, okay, this is F4 and the Cl is 0. And Cl is 0. Okay, so now in this case you are calculating Rm minus 1 n plus 1 into P, or n plus P plus Q, okay, is equal to 2m plus 2. So when the refrigerant is saturated hydrocarbon, in that situation, like R11, like R12, like R22, like R134, okay, so for all these refrigerant you can use this expression to find out the values of chemical formula of R134. Okay, already I have told you कि I will not discuss only the questions. Okay, indirectly I will discuss so many things, okay, which will help you in your exams. Okay, so intentionally I have taken refrigerant used is R134A so that I can explain and we can discuss about this thing. Okay, so R134A, okay, so m minus 1 is equal to 1, n plus 1 is equal to 3, P is equal to 4, okay, m is equal to 2, n is equal to 2, okay, P is equal to 4, okay, n plus P plus Q, okay, is equal to 2m plus 2. Okay, so Q is equal to 0. Okay, so CHFCl. So carbon M is equal to 2, this is 2, this is 4, and this is 0. Okay, so in this manner you can find out the values of R11, R12, R22, all these refrigerant. Okay, this is your case number 1 if you have attended my class. Okay, so in our class notes we have discussed this as a case number 1. So when the refrigerant is saturated hydrocarbon. Okay, now come to the VCRS concept. Okay, vapor compression refrigeration system. Okay, so condenser temperature is 35 degrees Celsius, evaporator temperature is minus 10 degrees Celsius, this is minus 10, this is minus 10. Okay, so I have highlighted more. Okay, maybe you are not able to observe, but negative sign is already given in the table, but I have highlighted. Okay, now compressor RPM is given, compressor efficiency is given. Okay, clearance ratio, swept volume is given in meter cube. Expansion index means the value of N. Okay, index. Condensate subcooling, so subcooling is also there. Subcooling means it is the process of decreasing the temperature at constant pressure below saturated liquid, and the Cp of vapor and Cp of liquid are also given, and the suction vapor is dry saturated and the compression process is isentropic. Okay, dry saturated, suction vapor is dry saturated at the entry of compressor. Okay, at the entry of compressor. Okay, at the entry of compressor. Okay, so whenever if there is no information is given in the question, in that case also we are taking always saturated vapor entry to the compressor and saturated liquid at the exit of condenser, Okay, so now what is the first most important thing for these types of question? The first most important thing, you have to draw the TS diagram. Okay, you have to draw the TS diagram. Okay, you have to draw the TS diagram. Now how to draw the TS diagram? The TS diagram, how to draw? The first most important thing, if there is no information given in the question. Okay, if there is no information given in the question, in that situation, okay, if there is no information is given in the question, in that situation always assume saturated vapor at the exit of evaporator and saturated liquid at the exit of condenser, Okay, at the exit of condenser. Okay, so now, but if some information is given in the question, okay, then please draw the TS diagram according to that. So now in this question, what is the important observation? The important observation is, this is point number 1, this is point number 2, this is 2 dash, this is 3, this is 4, and this is 5. In this question, the subcooling is also given. Subcooling means it is the process of decreasing the temperature at constant pressure below saturated liquid. Subcooling is given. Maybe in your time you will get a question on superheating. Superheating means it is the process of increasing the temperature at constant pressure above saturated vapor. Okay, but now in this question, what is the another game? The another game is this. The compressor efficiency is also given. My dear friend, the compressor efficiency is also given. This is the most important thing. Maybe if you are in hurry, you will not read this point properly, compressor efficiency, and then game over. Okay, so the compressor efficiency is given. If the compressor efficiency is given, it means that the actual work is not H2 minus H1. Actual work is not no, 1 minute, sorry. Okay, actual work. Okay, first I will explain the concept. Actual work is not equal to the theoretical work, that is H2 minus H1. It is consuming more amount of input. Okay, more amount of input, so means divided by the compressor efficiency, so that the actual work input or actual work consumed by the system is more than the ideal work. Okay, so if you want to show then you can represent in this manner also 2 double dash. Okay, 2 double dash, or you can say that the actual work is S2 double dash minus H1. Okay, S2 double dash minus H1. Okay, so now in this question the subcooling word is given, so indirectly you are able to solve the question of superheating also. Now in this question the compressor efficiency is also given. Okay, intentionally I have taken, but if you have seen the last 20 years of the GATE question, they are happy with only S2 minus H1. Okay, 99% of the time you will get a question based on ideal work only, that is S2 minus H1. But if efficiency word is given, in that case the actual work input consumed by the system is more than the theoretical work input. Okay, theoretical work input. Now the next step is, the first most important step is your TS diagram. The next step is find out the values of the enthalpies. So now see, minus 10 degrees Celsius, the value is 392.4. okay, 392.4 kilojoule per kg. Now H2 dash, okay, H2 dash is corresponding to this 35 degrees Celsius, so 417.6 kilojoule per kg. Okay, now H3 is corresponding to 35, and that is a liquid. Okay, that is a liquid, so 249.1. So this is corresponding to 35 degrees Celsius, this is corresponding to minus 10 degrees Celsius. And one more thing, in this case subcooling word is mentioned. The condensate subcooling is 5 degrees Celsius. So 5 degrees Celsius, so we can say that this temperature is 30 degrees Celsius. This temperature is 30 degrees Celsius. Okay, now first of all we will try to find out the values of H4. It is in subcooled state, so H4 is equal to H3 minus Cp of liquid into T3 minus T4. So what is the value of H3? The H3 value is 249.1 minus Cp of liquid. The Cp of liquid is given as 1.458. okay, the Cp of liquid is given as 1.45, okay, 458 into subcooling is 5 degree. Okay, so 249.1 minus 1.458 into 5. So this value will come out as 241.81 kilojoule per kg. 241.81. okay, 241.81. so now H5 is also having same value. Why? Because 4 to 5 is a throttling, and throttling means constant enthalpy process. Throttling always results a decrease in pressure. And throttling is a irreversible adiabatic process. Because of irreversibility only, 4 to 5 is represented by dotted line. Okay, so throttling. So now only one thing is left. Okay, the value of H2 and the value of S2 double dash. Now in the question clearly they have mentioned the compression is isentropic. Okay, the compression is isentropic. So I will assume S1 is equal to S2. Okay, I will assume S1 is equal to S2. Okay, S1 is equal to S2. So S1 is saturated vapor, SG1. 2 is superheated region, so SG2 dash plus Cp of vapor ln T2 upon T2 dash. Okay, T2 upon T2 dash. Now 0.1 is corresponding to minus 10 pe Sg 1.733. See the last column, 1.715, and the Cp of vapor is given in the question 1.1 kilojoule per kg Kelvin. Okay, 1.1 kilojoule per kg Kelvin. Okay, so plus 1.1 ln T2 is unknown. So how to T2 dash, capital T is the temperature in Kelvin. So 273 plus 35, that is 308. So 1.733 minus 1.715 divided by 1.1 and T log into 308. Okay, so from this you will get the value of T2 313.08 Kelvin. Okay, 313.08 Kelvin. Okay, now we can find out the values of H2. Now we can find out the values of H2. So sorry, okay, we can find out the values of H2. H2 is Hg2 dash plus Cp of vapor into T2 minus T2 dash. Okay, Hg2 dash. Okay, what is the value of Hg2 dash? 417.6. okay, plus Cp of vapor, that is 1.1. T2 value is 313.08 minus 308. Okay, minus 308 into 1.1 plus 417.6. So this is coming out as 423.18. okay, 189 kilojoule per kg. Okay, kilojoule per kg. This is the value of S2. This is the value of H2. But in this question, the compressor efficiency is also given. So in it means that the actual compressor outlet is not H2. It is H2 double dash. So the isentropic efficiency of compressor. So this is H2 minus H1 upon H2 double dash minus H1. So the compressor efficiency is given as 0.8. Okay, compressor efficiency is given as 0.8. So 423.189 minus H1. Okay, let me check the value of H1. H1 is 392.4. okay, 392.4. okay, upon this is 392.4 and this is H2 double dash. Okay, H2 double dash. So minus 392.4. okay, divided by 0.8 plus 392.4. so from here you will get the values of actual enthalpy at the outlet of compressor, means after considering the compressor efficiency. So 430.88. okay, 430.88 kilojoule per kg. okay, 430.88. so we will write here also 430.88 kilojoule per kg. okay, so now I think all the datas of enthalpies are known. H1 is known, H2 double dash is known, H4 is known, H5 and H4 are same. Okay, so I will repeat again. Please listen carefully. First, the most important step in the case of VCRS question is, first you have to draw the TS diagram. The one possibility is there is no information given in the question. In that case, what is your TS diagram? TS diagram is exit of evaporator is saturated vapor and exit of condenser is saturated liquid, right? The second possibility is with superheating. Superheating means process of increasing the temperature at constant pressure above saturated vapor. Third possibility is subcooling. This is the question. The process of decreasing the temperature at constant pressure below saturated liquid. Now the fourth possibility is the isentropic efficiency of compressor. Okay, the efficiency associated with the compressor is given. In that case, you have to consider that compressor efficiency, and what it means that the actual work input or actual work consumed by the compressor is more than the theoretical work input or theoretical compressor work. So first of all, I have find out the value of T2 by using S1 is equal to S2. Then with the help of T2, we are able to find out the value of S2, and from S2, with the help of isentropic efficiency, a compressor efficiency, we are able to find out the S2 double dash. Okay, so now what we will do? Now we will start finding out the values of RC power COP. But the important point is you have to find out the RC, you have to find out the power in kilowatt, RC in ton, and 1 ton is how many kilowatt? 3.5 kilowatt. It means you need need the mass flow rate. The first most important thing, you need the values of mass flow rate. Now, how to calculate the mass flow rate? What is the reason why I have taken this question? From a single question, I am trying my best कि you are able to revise your full VCRS chapter, So now see here, in this question we will find out RC. RC means m dot into RE, okay, divided by 3.5, and ton is power m dot into work. COP RC upon power. Heat rejection across condenser. Why this is important? Heat rejection across condenser, because if you are in hurry, then you will take H2 minus H4. No, actual output of the compressor is H2 double dash. So H2 double dash minus H4. So indirectly, all the topics, all the possible numerical questions are already included in this. Now, the last possible question is related to volumetric efficiency. So, how to calculate the mass flow rate? The mass flow rate is calculated by three ways: RC, power, and volumetric efficiency. So, in this question, the volumetric efficiency concept is also used. Okay, the volumetric efficiency. So now the volumetric efficiency is calculated by 1 plus C minus C. Okay, 1 plus C minus C. Okay, this is P higher upon P lower raised to power 1 upon N. I think you are able to understand the importance of this question. In this case, the mass flow rate is not given directly in the question, and the mass flow rate is calculated by how many ways? Three ways. RC, it is unknown. Power, it is unknown. Volumetric, again the problem is the volumetric also is not given. So now you have to use the both the expression of volumetric efficiency also. Okay, so please don't think this is a single question. In a single question there are 1 2 3 4. Fifth is volumetric efficiency, sixth is mass flow rate, okay, seventh is compressor efficiency. Okay, compressor efficiency used in a single question. Almost 7 to 8 questions are covered of your gate questions. Okay, possible gate questions. Okay, so now 1 plus C clearance ratio is how much? 0.03, okay, minus 0.03, okay, P higher. The values of the pressure are given 8.870 divided by 2.014, and the expansion index is given as 1.12. okay, 1.12. This is a separate objective question. Okay, so 8.870 divided by 2.014 raised to power 1 upon 1.12, okay, into minus 0.03 plus 1.03. So this is coming out as 0.9172. So 91.72%. So 0.9172, okay, it is equal to m dot, okay, it is equal to m dot V entry upon pi by 4 d square L n by 60 into K. Okay, V dot entry specific volume. So corresponding to minus 10, we need the value of Vg corresponding to minus 10. Okay, if you have solved the previous year PSU, different PSU and state level exam question and gate question, so this is a separate objective question. This is a separate objective question. This is a very important. Always take at the entry. So the specific volume is 0.0994. Okay, 0.0994, and the swapped volume is given directly. Swapped volume means pi by 4 d square L. So this value is given as 269.4, and that is in centimeter cube. So I will convert into meter cube. What is the value of RPM? RPM is 2800 upon 60 into number of cylinder are not given. If number of cylinder are not given, then taken as 1. So we will solve this, okay, into 2800 divided by 10 raised to power 6 divided by 60, okay, and divided by 0.0999. 994. So from here, okay, from here you will get the mass flow rate as 0.1160 kg per second, 0.1160 kg per second. First, please take 1 minute break and then observe carefully this question and then tell me up to this point you are correct or not. Up to this point you are able to understand or not? Correct? 0.1160. Clear? So it is not a single question. Again and again I am telling you the same thing. Okay, in a single question there are 7 to 8 possible gate question. We have discussed mass flow rate, we have discussed the volumetric efficiency, the basic formula, we have discussed the second basic formula of the volumetric efficiency. Now we will calculate the value of RC, then power, then COP, then heat rejection across condenser, then isentropic efficiency of compressor or compressor efficiency. So indirectly in a single question there are 7 to 8 your gate questions, possible gate questions. Okay, so now we will move towards our final thing, that is your RC. Okay, just now you have to put the values RC in ton. Okay, RC in ton. So mass flow rate, okay, mass flow rate into H1 minus H5, okay, H1 minus H5 upon 3.5. So refrigeration effect is the term related with evaporator. So into H1 is 392.4 minus 241.81, okay, divided by 3.5. So this will come out as 4.9916 tons of refrigeration. 4.9916 tons of refrigeration. Okay, now the question is a jog. Okay, so first step is you have to find out the values of enthalpies after drawing the TS diagram. The first is TS diagram, second is find out the values of enthalpies. So now the S2 double dash, so 430.88 minus 392.4, okay, into m dot is 0.1160. Okay, don't try to be over smart in the paper. Okay, please take care of the units. RC in tons, power in kilowatt. Okay, so try to find out, okay, find out the answers in terms of the required units, Now COP, so for COP you can use directly RC upon power input. Okay, RC upon power input into 4.9916 into 3.5. okay, don't be in hurry. This is in tons of refrigeration and this is in kilowatt, so convert this into kilowatt also. Okay, so RC, so 3.913. okay, 3.913. okay, and the heat rejection across condenser, so the condenser entry is 2 double dash and exit is 4. okay, H2 double dash minus H4 into mass flow rate, because we have to find out the heat rejection across condenser in kilowatt. So S2 double dash 430.88 minus 241.81 into 0.1160. So this will come out as 21, okay, 0.93 kilowatt, 21.93 kilowatt. So I hope you are able to understand the concept, okay, the main logic, why I have discussed this question, okay, before your gate exam, because in a single question I am trying my best, I have tried to take that particular question in which we are able to revise your all possible concepts and the possible questions, okay, they can ask in your gate exam. RC, power, volumetric efficiency, mass flow rate, COP, heat reaction across condenser, and efficiency of the compressor, and this is a question based on superheating. So now you will get, maybe you will get a question based on subcooling, you will get a question based on superheating, or maybe you will get the question based on without superheating and without subcooling, simple VCRS, in which the entry point to the evaporator compressor, entry point to the compressor is saturated vapor and exit of the condenser is also saturated liquid. Okay, saturated liquid. So that will be a basic question. Okay, so first read the question carefully, draw the TS diagram, find out the values of enthalpy. Don't be in hurry, don't be in hurry in the exam. You will get almost 3 minutes to solve a single question, but because of over excitement, if you will skip any step, maybe you will get the wrong answer and then there is no solution for that. Okay, there is, instead of getting the marks, positive marks, okay, there will be a negative marking also. Okay, so in your GATE exam, so please take care of your speed and accuracy. Okay, so this is your second question and I hope you are able to understand all the concepts which we have discussed in this question. Okay, so this is our next question, that is from your psychometry. A spray cooling coil is used to operate under the following conditions: air inlet 28-degree dry bulb and 21-degree wet bulb temperature. Okay, so this data is given. Air outlet temperature is 10 degree, dry bulb 6 degree, wet bulb temperature. Total air inflow rate is 2000 meter cube per minute. So if you have completed the class notes, okay, and so I think you are able to recall CMM, volume flow rate of air taken in meter cube per minute, CMM data. Okay, the chilled water inlet and outlet temperature are 7 degree and 12 degree Celsius. Okay, heat lost by one body is equal to heat gained by another body. So when you will talk about the psychometry, okay, when you will talk about the psychometry, again we will discuss the other things also. Okay, this question also and the other things also. On the psychometric chart, on this axis there is a dry bulb temperature, on this axis there is a specific humidity, and the relative humidity lines are parallel to the saturation curve, and specific enthalpy lines are represented in the northwest corner. Okay, northwest corner. So this is the enthalpy representation, this is your relative humidity, this is dry bulb temperature. This is increasing in this direction, the specific humidity is increasing in this direction, relative humidity is increasing in this direction, because for the saturation curve the relative humidity is 100%, and the enthalpy, okay, enthalpy, WBT, all are increasing in this direction, in this direction, in this direction. Okay, so there are so many processes. So first I will discuss the other information. The other information is what is sensible heating, a very favorite question of your GATE exam. Sensible heating, sensible cooling, humidification, dehumidification. So what is sensible heating? Sensible heating means it is the process of increasing the temperature. It is a process of increasing the temperature at constant specific humidity. At constant specific humidity. This is a sensible heating. This is a sensible heating. Okay, sensible heating. Now we will check the sensible cooling. Sensible cooling means it is the process of decreasing the temperature, dry bulb temperature. Dry bulb temperature, this is T2 and this is T1 and this is omega 1 is equal to omega 2. Dry bulb temperature at constant specific humidity, at constant specific humidity. Now the next important thing is humidification. This is 1, this is 2. This is the process of increasing the, okay, increasing the specific humidity, increasing the specific humidity at constant dry bulb temperature, at constant dry bulb temperature. Okay, and this is dehumidification. Okay, this is dehumidification. It is the process of, okay, it is the process of decreasing the specific humidity at constant dry bulb temperature, at constant dry bulb temperature. So this is a sensible heating, this is a sensible cooling, this is a humidification, this is dehumidification. Okay, so in your GATE exam, so many number of times they have asked the question based on these grad. So they will ask that during sensible heating, what is the impact on dry bulb temperature, specific humidity, relative humidity. We will see one. Okay, relative humidity. This is phi 1, this is phi 2. So dry bulb temperature is increasing. Okay, omega is constant. Okay, relative humidity is decreasing. Relative humidity is decreasing. Okay, next this is enthalpy. This is H1 and H2. Okay, the enthalpy is going to be increasing. Okay, the WBT is also going to be increasing because increasing order is same. And what is the impact on dew point temperature? The dew point temperature is constant because dew point temperature line are also horizontal and specific humidity lines are also horizontal. So similarly, okay, you can find out the answer for sensible cooling, for humidification, for dehumidification. Okay, humidification, dehumidification. Next important thing is maybe you can mix. Okay, not you, examiner is mixing. Okay, this is a sensible heating, this is a sensible cooling, this is representing humidification, this is representing dehumidification. Okay, now this is heating, okay, plus humidification. Okay, this is cooling plus humidification. Okay, this is cooling plus dehumidification, and this is heating plus dehumidification. So generally we are dealing with practically summer air conditioning and winter air conditioning. In summer air conditioning, cooling and dehumidification process occur. In winter air conditioning, heating and humidification process occur. And one more example is your desert cooler. In the case of desert cooler, okay, cooling and humidification or evaporative cooling, okay, or evaporative cooling occurs. Okay, or evaporative cooling occurs. So desert cooler, cooling and humidification or evaporative cooling. And one more word is also there, adiabatic saturation. Okay, adiabatic saturation. So if you have completed the class notes, so in case of desert cooler, maybe you will get cooling and humidification word or evaporative cooling word or adiabatic saturation process word. Okay, adiabatic saturation process word. Okay, adiabatic saturation process word. So in this question we have discussed indirectly the concept of sensible heating, sensible cooling, humidification, dehumidification, yeah, any combination, summer air conditioning, winter air conditioning, adiabatic saturation. Okay, and what are the impact on different parameters, dry bulb temperature, specific humidity, relative humidity. Okay, and dew point temperature line are also horizontal. Okay, so if omega is constant, dew point temperature is also constant. Enthalpy and WBT lines are increasing and decreasing order are same, but lines are different. Enthalpy lines are uniformly spaced and WBT lines are non-uniformly spaced. Okay, so intentionally I have taken this question so that I was able to discuss the other important things also. Now this question is very simple. Okay, very simple. Okay, so now see here, air inlet temperature is 28 degree and 21 degree. Air outlet temperature is 10 degree dry bulb. Okay, 10 degree dry bulb. So now from this data only you are able to understand, this is your point number 1 and this is your point number 2. Why? Because they have given 10 degrees Celsius dry bulb temperature and initial is 21 degrees Celsius. It means it is a case of cooling and dehumidification. Okay, now the volume flow rate of air is given as 2000 meter cube per minute of air. Okay, now corresponding to this the enthalpy values are given 61 and 21. Okay, this is 61, this is 21. Okay, now cooling load on the coil. So if you are my student, okay, if you have completed RAC from me, so I think you know this concept. I have already told so many number of times in the class that pick up the process high minus low, pick up the process high minus low. Now, so cooling load on the coil m dot h1 minus h2, but the problem is that the volume is given, the mass is not given. But if you will observe carefully, this temperature, okay, sorry, this is 28 degrees Celsius. This is 28 degrees Celsius. Okay, but it does not matter because we are not solving the question by the use of psychometric chart. These data are already given in the question. Okay, so m dot h1 minus h2. Okay, so the values of enthalpies are given, H1, this is H2, okay, the mass flow rate, and the corresponding specific volume is given, and the corresponding, my dear friend, the specific volume is given, 0.87. So specific volume is equal to volume by mass. So from this you will get volume flow rate upon specific volume into H1 minus H2. So what is the value of volume flow rate? 2000 meter cube per minute. So I will convert into seconds, and the specific volume is 0.87, okay, 0.87, and this is 61 minus 21, okay, this is 61 minus 21. So 61 minus 21 into 2000 divided by 60 divided by 0.87. So you will get answer as 1532.56 kilowatt, okay, 0.56 kilowatt. We will check the unit, the volume flow rate in meter cube per minute, but I have converted into seconds, and the specific volume in meter cube per kg, meter cube cancel, kg per second, okay, and the specific enthalpy are in kilojoule per kg. So this and this cancel, so from this you will get the answer in kilojoule per second, means kilowatt, okay. So by mistake I have written 21 degrees Celsius, but it does not matter because the value of 21 is greater than 10, 28 is also greater than 10. The value of dry bulb temperature is increasing in plus x direction, because here we are not using the chart, the values are already given in the question. So actually focus on the main concept, okay. So m dot h1 minus h2. Now water flow rate through the coil. Why water flow rate through the coil, they are asking? Because the chilled water inlet and outlet temperature are given as, so means the water is entering at 7 degree and leaving at 12 degree. Obviously the temperature of the water has to be increased. Why? Because the increase in temperature, heat gained by the water and heat lost by the air. So how much amount of heat is lost? So 1532.6, okay, 0.56, okay, 1 minute, 0.56, okay, it is the loss. So mass flow rate of water, Cp of water into delta T across water. So what is the value of Cp of water? 4.187, and this is increased by 5, okay, 12 minus 7, okay, 12 minus 7, yes, correct, 12 minus 7, that is equal to 5, okay. So divided by 4.187 and 1532.56 divided by 4.187 and divided by 5. So this will come out as 73.2 kg per second. So this is the mass flow rate of the water. Clear? This is the mass flow rate of the water. Clear? Okay. So this is the answer, and in this question we have discussed indirectly so many other questions, possible questions of your gate: sensible heating, sensible cooling, humidification, dehumidification, या any combination, okay, summer air conditioning, winter air conditioning, desert cooler, okay, adiabatic saturation, that is also called as, and during the sensible heating, cooling, या any of the process, how to find out the impact on different parameters like dry bulb temperature, wet bulb temperature, dew point temperature, specific humidity, relative humidity, okay. So these are the favorite questions of you for your GATE exam as well as for ES and for your state level PSU exams also, okay. So this is the answer of this question. I hope you are clear with the concept. So this is our next question, that is from your reverse Breton cycle, okay. So one question we have discussed on the basic concept, one question we have discussed on the psychometry, one question we have discussed on VCRS, okay. But that is not a single question. In every question 5 to 6, 7 to 8 possible objective questions of for your GATE exam I have discussed, okay. Now come to the reverse Breton cycle. An air refrigeration system operating on an open air cycle is required to produce, okay, 25 tons of refrigeration with a cooler pressure of 12 bar, and the refrigerator pressure of 1 bar, okay, The temperature of the air leaving the cooler is 25 degrees Celsius, and then air leaving the room is at 0 degrees Celsius, okay. Now first of all, we will draw its PV curve or the TS curve. Okay. Okay. So this and this is 1, this is 2, this is 3, this is 4. So this is a reversed Breton cycle. So reversed Breton cycle. Okay. So now in this case, this pressure is given as 12 bar. Okay. This pressure is given as 1 bar. Okay. Now this isentropic compression, this is PV raised to power 1.4 is equal to constant, and this is a very important part due to which I am discussing this question, and I have taken this question for your GTQ. Okay, why? Because the index are different. Okay, the index are different. On one side it is a compression, on another side it is a polytropic. Maybe both compression and turbine, okay, or expansion, both are isentropic. Maybe both compression and expansion are polytropic process. Okay, so why this question is important? Because if you are in hurry, then you will solve this question by using directly this formula, and then you will get the wrong answer. COP is equal to RP 1 upon RP raised to power gamma minus 1 upon gamma minus 1. Okay, this is the one possible question, but this is a theoretical COP. This is a theoretical COP, and the most important assumption, okay, you cannot apply this formula here because the expansion index is not isentropic, it is a polytropic. Okay, so this formula is applicable only when both compression and expansion are isentropic. Both. Okay, both means both. Okay, it is not like that ki if compression is isentropic you can apply, or if expansion is isentropic then you can apply. Because of this reason only, intentionally I have taken this question, because in this case one is isentropic but another process is polytropic. Okay, so both are isentropic. In that situation only you can apply. So in your time, okay, 99% of the cases in your GATE exam you will get a question based on theoretical, okay, theoretical COP in which both compression and expansion are isentropic. If compression and expansion are isentropic, then you can use this directly, otherwise please don't use. Okay, otherwise please don't use. Now next is first step is you have to draw the PV or the TS diagram. Second step is data, the temperature of air leaving the cooler. Okay, the temperature of air leaving the cooler, that is T3 is 298 Kelvin, and the air leaving the room is at 0 degrees Celsius, that is 273 Kelvin. Okay, so now the next step is we will find out, okay, we will find out the values of the temperature. Okay, we will find out the values of the temperature. So now T2 upon T1, okay, is equal to P2 upon P1 raised to power gamma minus 1 upon gamma. Okay, and T3 upon T4, okay, is equal to P3 upon P4 raised to power n minus 1 upon n. Okay, so now from this you will get the value of T2, and from this you will get the value of T4. Okay, so 12 raised to power 0.4 upon 1.4 into 273. So you will get 555.26 Kelvin. Okay, and here the most important part, the index is different. Okay, index is changed. So 12 raised to power 0.35 upon 1.35, okay, inverse into 298. So that is 156.46 Kelvin. Okay, I will check again, maybe if there is no mistake, into 298. Yes, it is right. Okay, T2 and T4 are right. Now the work input, so 1 to 2 is polytropic or isentropic. It is isentropic, but I will tell you the formulas, okay, by basic, because the compressor and turbine both are the example of open system, and open system formula is gamma times work of closed. Okay, gamma times work of closed, and close means initial minus final. So P1 V1 minus P2 V2 upon gamma minus 1. Okay, gamma minus 1. So gamma upon gamma minus 1 into mr into T1 minus T2. Okay, so gamma is 1.4 upon 0.4 per unit mass. R for air is 0.287. Okay, T1 is 273. Okay, 273 minus 555. Okay, minus 555.26. Okay, 273 minus 555.26 into 1.4 into 0.287 divided by 0.4. So you will get the value as minus 283.53. Yes, you are right. Why you are getting minus value? Why? Because the compressor is an example of open system, and compressor is a work absorbing device. Compressor is a work absorbing device, so it should be negative. Now similarly for 3 to 4, because it is following polytropic. Okay, polytropic, so now its formula will change to n upon n minus 1 mr, initial minus final. Here initial is 1 to 2, here initial is 3 to 4. Okay, so this is 1.35. Okay, 1.35 upon 0.35 into 1 into 0.287. Okay, into T3, that is 298 minus 156.46. Okay, so 298 minus 156.46 into 1.35 into 0.287 divided by 0.35. So you will get 156.68. We will check again. 298 minus 156.46 into 1.35 into 0.287 divided by 0.35. Correct. So this is a positive value and this is a negative value. So work net is the summation. So minus 283.53, this is a negative compressor work, and this is a turbine work, this is a positive, because right now we are studying RAC. RAC is a reversed Breton cycle, means work absorbing device. So the net work output, okay, net work output should be negative. So here you will get negative value. So from this also you are able to understand, that this is a case of work absorbing device. On the PV curve it is anti-clockwise, on the TS curve it is anti-clockwise, and mathematically from the value of work net you can say that it is a case of work absorbing device. So the work input is 126.84. Work input is 126.84. Work input is 126.84. Okay, 126.84. Now one thing is left. Okay, now one thing is left, that is refrigeration effect. Okay, refrigeration effect. So refrigeration effect per unit mass. Okay, per unit mass we can calculate by H1 minus H4. So this is Cp into T1 minus T4. The value of Cp of air is 1.005 T1. Okay, T1, how much is T1? 273. Okay, 273 minus T4, 156.46. okay, 273 minus 156.46 into 1.005. so this is, you will get, okay, 1 minute, you will get 117.12. okay, 0.12. okay, 0.12. clear? So now this 1 minute here. Okay, COP, refrigeration effect upon work input, so divided by 126.84. so you will get 0.923. okay, you will get the answer as 0.923. so now from here I think you are able to understand, so many concepts like Theoretical COP formula you can apply. Theoretical COP formula you can apply. Okay, if both compression and expansion are isentropic, both. Okay, it is not like that. If only compression is isentropic, turbine expansion is polytropic. Yeah, if expansion is isentropic and compression is polytropic, so you cannot apply. Okay, so due to this reason, I have taken intentionally this question. Okay, so the first concept and the most useful concept. Okay, in 99% of the question, you will get the value of pressure ratio. Gamma for air is 1.4, and you can use this formula directly to find out the value of COP. But in this question, the value of COP you cannot find out by this, because the compression is isentropic, no problem, but the turbine expansion is polytropic. So in this case, we cannot apply this formula. Okay, because if you have completed my classes, then you are able to understand how this formula is derived by using both compression and expansion isentropic. I have discussed in so much detail in your classes. Okay, you can refer the class notes, but there is no need. The important point is this only. So now we have find out the value of T2, then find out the value of T4, then compression work, then expansion work. Compression is a negative. Why? Because it is a work absorbing device. Turbine is a positive. Why? It is a work producing device. Net work is always a negative in this case, because right now we are dealing with the work producing or work absorbing. We are dealing with work absorbing device. So when you will solve the question of IC engine and power plant, you will get net work output, okay, as a positive value. That's why in IC engine, in power plant question, you are calculating the value of efficiency. Here we will get the value of work net is negative. It means that it indicates that our system under consideration is a work absorbing device, and it is a case of work input. The work input is this. Okay, so due to this reason, in RAC subject, in refrigeration subject, we are not calculating the value of efficiency, we are calculating the value of COP. COP is equal to refrigeration effect upon work input. The refrigeration effect is the term related with refrigerator 4:1 H1 minus H4, because in the calculation of compressor and turbine work, I have considered the mass as 1. So due to this reason, here also I have considered refrigeration effect in this calculation, the mass as 1. Okay, because the COP is the ratio of these two factors. So if you are considering the mass also, in that case also you will get the same answer, because in numerator also there is a mass term, in denominator also there is a mass term. Mass will get cancelled out, and from there you will get the values of COP. From there you will get the values of COP. I hope you are able to understand this concept. Okay.